Hey geometers, welcome back to another video lesson for our year-long geometry class. My name is Mr. Forster, and a few of the asynchronous tasks that you have for today, which is Friday, September 11th, is you have our Unit 2, Lesson 1, which is our Intro to Transformations. That's the video that you're watching right now. And then if you haven't gotten to it already, there is a homework assignment in Delta Math. That is our translations assignment. And so Delta Math, go back and watch the video from Friday's class, and it has instructions on how to get logged in. But that's going to be a new platform for us to do some assignments, and that allows me to give you some immediate feedback since Delta Math kind of does the feedback for me. And so we'll be mixing that in with some of our other assignments moving forward. So that way you can get immediate feedback on some of those assignments, and then I can give some more pointed feedback through Kami and some of the online interface there, and just takes a little bit off my plate, makes it so where I can give feedback without me being the only thing that gives you feedback, if that makes sense. So let's get into it. So we have this list of things called transformations, and we'll be going through some definitions that tie into this, and then we'll see some examples of our first type of transformation on our next slide. Short lesson for you today. So a transformation is something that we're talking about, specifically a geometric figure, is some change in its position, shape, or size. So if I make some kind of modification to that object that moves it around, we can slide it, we can flip it, we can spin it, we can even stretch it a little bit or smush it down. And so we're going to be talking about those types of things over the next few lessons. But a couple things to keep in mind, some of the definition pieces. Pre-image, that's the before, so it's the original figure, it's where we start before we have a transformation. And then the image is the result or the after, and so it's where we land when we're done applying this transformation. A special type of this transformation is called an isometry, and it's where our pre-image and our image are congruent. And again, congruent is same shape, same size, all the measurable attributes of that figure are the same. A couple of examples of transformations is we have something called a rotation, and another example is something called a dilation. And if we're identifying which one of these is an isometry, a rotation is an isometry because it stays the same shape and size, but a dilation creates a stretch, so it is not an isometry. All right, our first transformation that we'll play with, and we actually did this during our Desmos activity today, is called a translation. And so a translation is a slide where a figure or a point moves a certain distance in a certain direction. And more often than not, when we're talking about working within a plane, our Cartesian coordinate plane, we're going to talk about how it moves algebraically by using those x and y coordinates like we did today during that Desmos activity. So one way that we can write our rule is that if we go from some xy coordinate, then we're taking that point in each of the points in our figure and we're shifting them or sliding them by x plus whatever a value is. So if we're moving to the right or left, we're describing it in our x-axis. So to the right would be like, it would be x plus 1 would be 1 unit to the right. X minus 1 would be 1 unit to the left. And then we do the same thing for y. And so a and b are just placeholders for values that we would be describing our rule by. And so we'll see some examples of that here shortly. All right, in our first example, here we have example 1. It says find the image of the point B, which is at 3, -4, after it's been translated left 5 and up 7. So B is going to be, if I'm going to go over from the origin here in the middle, I'm going to go over to 1, 2, 3, and then down 1, 2, 3, 4. So here's my point, which I'll label with a B. And I'm going to shift it and translate it left 5 and up 7. So I can go over 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5, 6, 7. Now I've created a new point, and I'm not going to name this point B, but this is going to be my new point. So what I'm going to do is I'm going to use the letter B again, but I'm going to add this little 1 up above it, and that 1 stands for prime. So this is called B prime, and now I've taken B and I've translated it left 5, up 7, and I have a new point which we call B prime. Moving on to our second example, it says, given the transformation below, which you'll have to add into your notes, describe this translation. So we're starting at x at 2, 1, and we're ending at x prime, which is at 0, -4. And so the way that I would describe this is I've gone from 2, which we'll highlight here. We've gone from 2 to 0, so I've gone left 4. And then we've gone from 1, again I'll highlight here in orange to match the description down low, 1 down to -4. All right, our third and final example, it asks us to write a rule to describe the translation from PQRS, which is the figure in black here, to P prime, Q prime, R prime, S prime. So this is our pre-image, and this is our image. We're going to go to the blue figure. So one of the ways that I can describe this is I can say in words that I'm translating this up. So the black figure moves up by 1 unit and left 4 units. And then with algebra, I would describe that as the left part is x -4 and the y part is y +1.